Hello everyone, it's a pleasure to be able to participate in today's Tech Network meeting. I am excited to introduce Kmesh, our kernel-native sidecarless service mesh dataplane project. I will introduce the background and architecture of the Kmesh project in several parts and explaining how Kmesh and CNCF benefit each other. Currently, the most mature service mesh architecture is sidecar, but the sidecar architecture has two major pinpoints. The one is the proxy layer brings extra latency overhead. Single hop service accessing increasingly by 2 or 3 milliseconds, which cannot meet the requirements of the latency sensitive applications. The other one is resources consumption of the sidecar increasing as the number of services increase. This hit the use of service mesh in large-scale applications. Take Istio as an example. The performance overhead caused by service mesh infrastructure is as follows. As can be seen from the picture, there is about 3 millisecond deny even without traffic distribution, and they are gradually increasing as the number of the connection increase. Therefore, in order to make up for the shortcomings of the sidecar architecture, all major service mesh communities have proposed their own solution. A variety of the architecture are brewing. The Selenium community compare ebpf with Envoy, proposing a sidecarless service mesh, Selenium mesh. For the layer 4 protocol, Selenium mesh use ebpf as an efficient kernel data routing for high-speed processing. For application layer protocols use Envoy as a passing. Because Selenium mesh level 7 governance capability is implemented through Envoy, resulting in a 2-hop increase in the number of link hops for layer 7. And the Selenium mesh felt in solution problem of the governments needed to be resolved. Ambient mesh is another sidecarless solution proposed by Istio community. Uses eternal and waypoint provides more efficient traffic management. The processing of traffic is all in the user space. There is no overhead of switch between user space and kernel space, but it also leads to more complex handling of traffic interception compared to sidecar. In addition to analyze the existing solution in the industry, we also analyze the times consuming of traffic distribution. We found traffic orchestration occurred only 10% of the overhead. Most of the overhead is caused by like data copy, two more link setup, and contextual switching scheduling. After understanding the dependencies of the existing sidecarless service mesh in the industry and the distribution of the orchestration overhead, we hope to bring service mesh back to the origin of cloud-native requirements and achieve an application transparent, high efficiency, and low network noise service mesh dataplane. Moreover, in the background of the big data and the large-scale business, we are aiming to achieve zero overhead network noise and minimize the resource occupied by the service mesh as much as possible. Overall, we need to address the following challenges. First is high reliability. We think established link should not be affected during infrastructure update or reboots. Second is minimize the CPU and the memory's resources occupied by the service mesh as much as possible. Third is provides flexible governance modes to meet the different needs of different users. Ultimately, our proposed solution is to shrink traffic governance into the OS kernel and implement our kernel native sidecarless service mesh data plan, Kmesh. Kmesh is a high performance and low overhead service mesh data plan based on ebpf and programmable kernel. Kmesh brings traffic management, security, and monitoring to service connection without need application code change. It is natively sidecarless, zero intrusion, and without adding any resources cost to application container. The advantage of Kmesh are as follows. First is high performance. Kmesh has lower latency than ambient, and application bootstrap improved by 40%. Second is low overhead. Kmesh is sidecarless service mesh data plan. Resources computation down by 30% and more. Third is high availability. Kernel traffic management does not terminate connections, and Kmesh component upgrades and restart do not affect existing service connection. Fourth is security resolution. Kmesh uses ebpf. BPF-based VM security and C group level government resolution are supported. Now, 5 is flexible management mode. Kmesh has two modes. One is kernel native mode for extreme performance. The other one is dual engine mode for flexible deployment. Both of each will be described later. The final is seamless compatibility. Kmesh seamlessly integrates with CHDS protocol, support both ECDO APIs and gateway APIs. There is two modes of Kmesh, kernel native mode and dual engine modes, in order to meet the different needs of different users. Kernel native mode has the ultimate in performance with no increase in link hops for either 4-layer or 7-layer connection, reducing latency by 60%. We have enhanced the kernel with ebpf and KO. Besides use connector fake TCP connection to complex traffic management in application layer. The simple description is that we fork a link through the kernel, and then manage the traffic once the client sends the message. We can see the first send message and not first send message. Kmesh will have different handle. Dual engine modes spreads the governance of 4-layer traffic and 7-layer traffic. ebpf implements traffic interception and simply traffic governance in the kernel, where the remote viewpoint implements complex governance of the application layer traffic. Dual engine modes look similar to the ambient mesh. But Kmesh implements traffic interception in kernel space, which is simple and more secure compared to ambient mesh interception of traffic in user space. Compared to kernel native mode of Kmesh, dual engine mode reduces the dependencies of kernel vision and lowers the threshold of user. The two mode of Kmesh has lower latency and less resources consumption compared to ambient mesh, and they can both upgrade and restart components without affecting existing connections, have high availability. The feature above is performance analysis of still ambient and still sidecar, as well as performance analysis comparison between Kmesh and still ambient. From the graph, we can draw the following conclusions. First is Kmesh ambient is faster than the still sidecar. Second is Kmesh is faster than ambient mesh by about 20% to 30% in the graph on the right. Therefore, we can conclude that the performance of Kmesh is better than that of ambient, but they're both slower than the baseline with layer 7 processing. This page shows about Kmesh's performance in cloud-native integration is as follows. One is submit in CNCF landscape in 2024. Two is Kmesh as a service mesh data plan runs on KBS and manage traffic from all two ports, and interacts with Istio subscriber TDS configuration from IstioD. Another one is Kmesh can work as an exporter of Prometheus and collocation data from observability. The figure also shows other cloud-native integration, including use IstioD as a control plane based on the TDS protocol, work as exploiter of Prometheus collector telemetry data between cloud-native service, and use Waypoint, which is a data plan that uses Envoy to handle complex traffic. The level 7 traffic at level 7 traffic. This page shows the reason for choosing CNCF and the benefits of Kmesh to the landscape. The CNCF is at the forefront of the fostering innovation and collaboration within the open source community, and gathers the goal of increasing community engagement and project adoption. Second is enhance Kmesh visible and capability within the cloud-native landscape, providing the opportunity to collaborate with like-minded developers and user. Greater exposure of the CNCF will lead to increasing feedback that can guarantee Kmesh developments is not out of date and out of touch. Exception Kmesh to join CNCF would bring the following benefit to the landscape. Kmesh is natively sidecarless, gains a substantial industrial advantage over resources, overhead, and latency. Kmesh exploded with the industrial development direction of layered traffic governance and remote application layer governance, reducing the resources overhead of service mesh. And Kmesh and providing a high availability service mesh data plan with update or restart infrastructure where doesn't influence application traffic. This is the traffic roadmap. This is Kmesh roadmap. Kmesh already support Harmon deploy, support dual engine bypass mesh observability association, IPv6 and DNS type service. We plan to support restart critical break rate limit, upstream extension, and MTLS in September. And release 1 in the December with locality-aware load balance, support multi-cluster DNS service, handless service, and integrate with gateway. Then in 2025, we introduced AI capability to enhance Kmesh in 2025, such as quickly locate the problem, improving the efficiency of traffic government's decision. Others include multi-VPC and use ebpf and APM enhance our observability, like tracing. This page lists some of the basic code of Kmesh community, such as website, repo, contributors, and lessons. Next, we can watch a video showing the Kmesh feature about white load balance. Other future demo video links are shown above. If you are interested, you can watch it on YouTube. My presentation is over. Thank you for listening.